Compression socks exist as a solution for patients suffering from chronic venous insufficiency. This occurs when blood pools in the lower legs. If unaddressed, this can cause pain and inflammation, which can eventually lead to deep vein thrombosis or varicose veins. Unfortunately, the user noncompliance rate for compression socks is somewhere between 30 and 65%. Investigation revealed that noncompliance is often a result of decreased mobility and dexterity of users, along with aesthetic opposition to compression socks currently available. Our team was tasked with the design of a compression sock with improved accessibility, comfort, and aesthetic appeal, while evenly distributing 15 millimeters of mercury of pressure to the user's lower leg.
In order to apply the appropriate amount of pressure, we determined the elasticity of Spandura nylon spandex fabric commonly used in compression socks on the market today. From this, we were able to create fabric dimensions that apply 15 millimeters of mercury of pressure evenly across the lower leg. When laser cutting the component, we added small cutouts lining the edge of the fabric for eyelets. This component acts as the sock body and covers the user from just below the knee to the ankle.
Using the same nylon fabric sandwiching a layer of 60-inch micro-suede polyester, we created a tongue that prevents the leg from exposure as laces pull across the front of the leg. The tongue is also laser cut and attached to the sock body at the ankle. The foot component of the sock was taken from a moderately priced standard sock available on Amazon. It is cut at the ankle and sewn to the base of the sock body.
A ratcheting mechanism is then sewn to the top of the sock. The mechanism is a BOA 2 gear replacement, which is a part commonly used to tighten snowboarding boots. It was modified with the addition of 3D printed components to enclose the gear system and affixed to the tongue of the sock.
Eyelets are affixed to the holes in the sock body. Woven fishing wire is laced through the system. Woven fishing line is used in this case for its lightweight and low friction.
As the ratcheting mechanism is turned, the user is able to tighten their compression sock to apply the appropriate amount of pressure to the user's lower leg. This design limits the distance that low mobility individuals need to reach when fastening the compression sock. It also eliminates the need for a tight grip on the sock for low dexterity users.
In order to validate the prototype, we want to conduct pressure and force to don tests. We also want to consider various tongue materials, sewing methods, and aesthetic modifications.